everyone. So this is if you were gone from class or by chance want to see the notes again. So I'm in the pink packet and I am on page 57. And we're just going to go a little bit more over factoring. And unfortunately, the cheat sheet that I had us made in one class is not in front of me because it's in the classroom. So I'll just kind of be talking about it and hopefully you have that cheat sheet. So the first thing I want to go over is this thing called the fundamental theorem of algebra, and it just basically tells you if you look at your polynomial function and you look at its highest exponent, okay, then that is going to tell you the number of answers you should have in your problem, okay? So according to this, I will end up having 3 answers. For this one, I'll have 5 answers, and for this one, I'll have 5 answers, and then for this one, I'll have 3 answers. So as far as the factoring goes, pay attention to the directions. So solve means we want to, what number if I put it in for x and did all the math would give me 0. But when we do solve, it has to equal 0. Finding the zeros means we're just going to set this equal to 0. So let me turn on the light here so you can see all that. And same with sorry, too much stuff, my paper won't move. Same with number 5, find the 0, so I just set it equal to 0. And the last one is solve. Again, solving means I do want to see what number if I put it in for x would give me 25, but to solve, we actually need to move the 25 over. Whoops, and I'm messing up. We need to move the 25 over so that it equals 0. So I would just subtract that 25 over. So let me quickly fix this because I need to write 5x minus 25 equals 0. So we're just going to start and we're going to kind of go in this pattern here. So in the first one, when I solve, the first step for all solving or factoring is a GCF, which when I look, I can factor an x out of all of these. And then I'm left with x squared, I'm left with a 4x, and I'm left with 4. And then once you have your GCF, you want to factor more. So when you have 3 terms, that is where we make our x. And remember, we multiply that for the top part of the x. And this is the bottom part of the x. And so I'm looking for factors that multiply to give me 4 and add to give me negative 4x. And that would be a negative 2x and a negative 2x. So again, when I multiply these, I get the x squared. But when I add these, in order to add, you need like terms. And so I need to make sure that these are both x's to get to here. So joining my GCF of x, I'll have my new factors. And again, this is, what neighbor to make x squared. It's just going to be x and x. And then I like to draw those loops. And I'm going to use these side numbers to determine the loops. So x times what would make negative 2x? And that would be a negative 2. And I can get that negative 2x there. And then x times what can make this negative 2x? That would be another negative 2. And so I'm able to get those numbers filled in. So this has been factored all the way. Anytime you think you're done factoring, always double check to see if there is a difference of squares. So these both have a difference, but this doesn't have a perfect square root, which means this doesn't, and neither does 2. So we are done factoring, and then when you're done factoring, you just take each factor, you set it equal to 0. Okay, and then what makes it 0? So this one is solved, it's one answer. This one I would add 2, and then this one I would also add 2. And so I do have 3 answers, and it is important that you realize that 2 appears twice because when we do graph, that's going to come into play. All right? Okay, moving on to number 5. So on number 5, the first thing I'm going to look for is a GCF. So again, I can take an x out, and this is what I'm left with. And then because there's 3 terms, I'm going to make my x. So it's going to look similar to the problem that we just did, but we have higher powers that we're working with. So multiplying that, that would be the top part of my x. And then this would be the bottom part. I'm going to go ahead and put a 1 in there. And so now I need factors of this that give me this. And that would be a 4 and a 3, with the 3 being negative. But again, I need to have x's here, and so remember, if this adds to this to make x squared, that means these had to start as x squared to begin with. And when I multiply these, I get the negative 12, and the x squared and the x squared make the x to the 4th. So I'm going to bring down my GCF, and then for here are the factors that are going to appear. And what times what makes x to the 4th? Well, that's just an x squared and x squared. And I'm going to draw those loops again and focus on this. So x squared times what would make this? That would be a positive 4, so I can get that 4x squared. And x times what can give me this? That would be a negative 3, so I can get that negative 3x squared. And then again, whenever I think I'm done, I'm going to double check a difference of squares. So this has the difference, but this doesn't have a nice square root. And these have nice square roots, but there's not the difference. So as far as factoring goes, I am done factoring. So I'm going to take this, set it equal to 0. I'm going to take this, set it equal to 0, and this, and set it equal to 0. And again, here's my first answer. That one's done. For this one, I'm going to isolate x by adding 3. And then to get rid of the square, I'm going to square root. And remember, when you square root, you get a positive and a negative version of that answer. If you'd like to find out what the square root of 3 is, you can. Otherwise, you can just leave it as the square root of 3. Okay? So for this one, to isolate x, I'm going to subtract 4. And then to get rid of the squared, I square root. So when I square root, remember, I get 2 answers. The square root of 4 is 2, but since we're taking the square root of negative 4, in a previous video, we did switch the setting on our graphing calculator. So just a reminder, we pressed mode right here, and we went to the row that said real, and you want the a plus b highlighted. So when you do that, and I take the square root of negative 4, I won't get an error message, I'll get the I that comes with it. But again, the calculator won't tell you the negative 2i. It doesn't solve for you, it just tells you kind of straight out facts of what the square root of negative 4 is, which is technically 2i. And again, 5 answers. Here's 1, 2, 3, 4, 5. All right, let's move to this one. So in this one, when I look for a GCF, I don't see one. But when you have 4 terms, we do this thing called grouping. And that's where I group the first 2 in parentheses and the last 2. And I want to make sure that minus is attached to this so it looks like a negative. And then I'm going to go to the first set and I'm going to look for a GCF. So I can factor out an x squared out of both terms. And then I'm left with an x plus 5. So I'll do the same thing here, but it has to be very specific. So when I do take out a GCF, I need to make sure that what I'm left with is x plus 5. These have to match. And that will force you to take out a certain number. So what times x makes negative 5x? Well, that would be a negative 5. And then I like to draw another bracket connecting the things that aren't in parentheses, because then the brackets are telling me my 2 factors. So one of them is the matching set, and I only write it once. And the other are the things that are outside, so x squared minus 5. Again, I think I'm done, but I'm going to look for a difference of squares. So first, this is addition, it's not a difference, so not there. This is subtraction, so it is a difference, but 5 does not have this nice square root, so I'll just leave it as it is. And then again, I just take each factor, I set it equal to 0. Here I would just subtract 5, so there's one of my 3 answers. Here I would add 5, and then to isolate x I would square root, and this time I'll put the decimal version, because the decimal version will be helpful when we graph, and this is 2.24, but again there's a positive and a negative version of that answer. So now I have my 3 problems, okay, or my 3 answers. So on the last one, since we're in a COVID year and we don't have as much time together, we do kind of have to decide what's really important to teach and what would be nice to teach. And over here, what I could have added to our cheat sheet is this way of factoring 2 terms called a sum or difference of cubes. So if you're interested in that, that'll be another video that'll be available in the week 2 Schoology folder. But otherwise, we're going to solve this without knowing how to do a difference of cubes. So I start the problem still by a GCF, and I can take an x, whoops, I wrote that wrong. I can take 2 x's out, and when I do that, I'm left with x cubed minus 8. So this is something called a difference of cubes, but I'm not going to show you because we can survive without it. So I'm going to go ahead and just set my factors equal to 0. I'm going to set this equal to 0, and I'm going to set this equal to 0. And again, to isolate x, I'm going to take the square root, which the square root of 0 is just 0. But remember, that exponent does say there are two answers, and usually there's a positive and a negative version. And I know that 0 isn't positive or negative, but we're going to write down 0 twice, because when we graph, that is very important. As far as this one goes, I can actually just isolate x by adding the 8 and then taking the cubed root of 8, which is 2. So what happens is we're supposed to see 5 solutions, but we're only seeing 3. Because of me not showing you the sum or difference of cubes of factoring, what we're not seeing is that you actually get 2 imaginary answers out of this set, which is okay because that we don't know exactly what they are, because when we graph, we don't graph imaginary numbers, we only graph real numbers. So from there, what I want to talk about, if you were gone, because we did do this as a group, is in the white packet. Let me explain what the homework is. In the end, between this week, I wanted page 54 and 55 done. And on 55, it says using your graphing calculator, but what we did in class is we used Desmos. So I just want to switch over to Desmos to show you how we got some of these key answers. So just give me one moment. I'm going to switch to Desmos. So just to back up, I am on page 55 in the white packet, and I'm looking at problem 9. And I'm going to type in the equation that follows g of x, which is x cubed minus 3x plus 1. So x cubed, to get the cubed, you go to the 6, and you'll see that little caret key, and I just hit shift 6, and it raises my exponent up. And then to get out of that, I just hit the right arrow, and I put the rest in. And the nice thing about the Desmos is that it does everything for us. So what happens is when we graph a shape and we need to know all these important points, when you just tap on it, you're going to see the key points. So we always need to know the X-Intercepts. So I'm showing them to you. And we need to know where it turns. And what Desmos also shows, which we don't really need, is the Y-intercept. So what we did first on page 9 is hold on, let me switch over, is we just drew a picture. And write whatever Desmos says. It will give you 3 decimals, and then we added the arrows. So this arrow is infinity, infinity, and this one's negative infinity, negative infinity. All right? So if you just want to pause and get that written down, that's great. So then what we did as a class is we checked out problem E and G and F. So let me just show a little bit of E right now and what this says. So it says evaluate G of 5.7. So that means x is 5.7, and there's the long way of doing it, and there's the fast way, Desmos way of doing it. The long way of doing it is I would actually just go to this equation at the top, and I would just put 5.7 in. So 5.7 cubed minus 3 times 5.7 plus 1. And notice when I put 5.7 on paper, I always wrap it in parentheses, and then I could just type this into my calculator and get the answer. But Desmos lets you do this as well. So this is x, and if you go to Desmos, which I'm going to switch over to Desmos now, is up here is this little wheel cog, and if you tap on that and then tap on this, you can have a table, and I can type in any x value that I want. So if I just put in 5.7, I can automatically see what y is going to be. All right? And then I can write that answer down. So g, when x is 5.7, gives me this answer. So the next thing we did was F, and the idea is you want to find the average rate of change, which is just slope, given these x values. So if x is 0 and if x is 3. And again, I could do what I did up here and put 0 in and put 3 in and let the calculator do the work. But I can also go to Desmos and go back to this table and type in 0 and 3 and then get those y values, right? So here's one coordinate, 0, 1. Here's the other coordinate, 3, 19. And then there they are. And then I can write my slope formula, which is a fraction bar, and you put the y's in the numerator. So we chose 19 minus 1, which is 18. And then I'll have to subtract the x's the same way, 3 minus 0, which is 3. And then average rate of change always goes one step further to get the denominator to be 1. So we just divided that and we got 6 over 1. The final one that I want to talk about is on G, and there is a typo. So it says find the two, it's actually 3 values of x where g of x equals x squared. And so on the graphing calculator, what we would have done there is we would have already, had our x cubed equation in a y equals, but then since there's another g of x, I could put that in a second y equals, and then we would have seen where they intersected. So, and then we would have done second trace and chose intersect. So instead what we did is we went to Desmos, going back there, and I don't want this table anymore, so I have 2 options. One, I can just get rid of the whole thing and retype the equation, but if you hit this arrow, it's just going to undo everything until we get back to the equation. And then you can go to 2 and just type in your other one, and then you're going to notice where the 2 shapes intersect. I want those x values, so this negative 1.481, the 0.311, and the 2.17. And that's what we covered as a class. Now, if you want to check out the answer key for pages 54 and 55, just check out week 2 in Schoology. So just popping back to my document, these were the final answers for G. I just wrote the x coordinates, and that's it. Man, I don't know. I don't think I stopped my recording yet.